Hi guys, welcome to Project 3. You are going to continue working with your command shooter, but we have some extra requirements for this project. So, first of all, we want you to bind two different buttons on your controller, each to a different RPM. That means that you can press one button, have it run at one RPM, press another button, have it run at a different RPM. This is something that you would likely have to do in an actual FRC game with shooting. But part of the challenge is both buttons should use the same command. That means that you should only have one shoot command in your whole project for shooting at an RPM. Unlike in the past, where we've written a command for shoot 1000 RPM, you might be tempted to write another command called shoot 2000 RPM, for example. But this is inefficient, and as you start to get to a lot of different RPMs, you're going to be making a lot of commands. It's not very modular. So we want you to use only one command. You should have one file called shoot command. This command should end once the shooter reaches the RPM requested. Additionally, you should have a smart dashboard boolean that shows true once the shooter has reached the RPM and false when the command initially runs and has not yet reached the RPM. Now, that's kind of a lot, so here's some hints. First of all, remember your unit conversions. Remember that the native units of your motors is in revolutions per second, so make sure that you have that conversion somewhere in your code working correctly. Another hint is to consider what method tells the command when to finish, especially when looking at requirement number 3 for the command ending. Another hint is consider what method gets the shooter's RPM, and think about how you could use that alongside your desired RPM, the one you want to reach, to determine requirement number 3. Also, think about what part of the command runs right when the command initially starts, looking at that requirement number 4's false clause. And finally, think about what part of the command runs when the shooter does reach its RPM. Consider hint 2, you shouldn't need to write a whole lot of extra code. Now remember, the way that the basic WPILibSim works is that it doesn't actually give you an RPM reading accurately. So even after writing out all this code, if you simulate, it might not show any RPM values. It might just always stay at 0, and your boolean might always stay at false. So we want you to compare to our example down in the description once you have completed this to the best of your abilities. And you can even download our example because it has some extra simulation code that will actually allow you to see the RPM run, and you can even play around with changing up the PID to enhance your understanding of what you've learned throughout this chapter. Good luck, and hope you have fun working with PID and your command shooter.